expressing this in the form of this is where you realize if you have, let's just make sure, you know that if you, say for example, have 2x plus 1 squared, you know for a fact it's going to create a 4x squared component, and the 2x plus 1 is going to have two of those, which are plus 4x plus 1 like that. So my point is, you'd realize if you're trying to express this in this form, you're not really changing what's being represented. You still have to make sure this overall thing simplifies into a 9x squared. And you realize there's only one number over here you can replace the a with. Because ax times ax has to create 9x squared. That's the only way you're going to create the x squared component, which is where you realize that it has to be a 3. 3x plus b has to be 3x times 3x, which is 9x squared. Plus b over there. So you see what I mean? Like the first thing we did would have been 9x squared minus 6x plus 6 equals to 3x plus b squared plus c. And this b over here is whatever number times 3, two of those creates minus 6x. Because that's the relationship from squared, isn't it? 3x times b, there's going to be two of those that have to create the minus 6x. Because on the right-hand side, there's nothing else that's going to create the x. And you realize it's going to have to be negative 1, isn't it? Because negative 1 times 3 is going to be negative 3x. Two of those gives you minus 6x. That's how you knew it was a minus 1 over there. Once you have 3x minus 1 squared like this, how do you create the plus 6? What do you have so far when you have this? It's going to be a plus 1. What do you need to include over here to make a plus 6? Oh, plus 5. And that's how we got the first part. 3 marks. If you really understand the relationship here, it's very easy 3 marks to obtain. Part B. Smallest value of p for which it is a 1-to-1. Do you see why it's so important we looked at the 1-to-1 definition, that tutorial over there? Quick one, but you get the context of what 1-to-1 means. Right now you have a parabola. A parabola is not 1-to-1. You know it's not 1-to-1. But if you introduce a certain condition, it's going to be 1-to-1. My point is this. When you look at the parabola over here, 9x squared minus 6x plus 6, just have a look at this, in case you don't understand basic concepts here. Let's put this into context here. Look at the actual graph over here. In the actual exam, you're not going to have the graph. But if you had the graph over here, just for understanding right now, if you had y is equal to, or let's even do f of x equals to, as is, just have a look at this. Let's have a look at this. Is this 1-to-1 right now? Obviously not 1-to-1. But if you were to introduce a certain condition over there, for say, is this the number 1 over here? Yep. What if we did x bigger than 1? Is this 1-to-1 now? Yes, it is. What about if it was less than negative 1? Is this 1-to-1 now? Yes, it is. So my point is this, right? If you introduce a certain condition, you can make it 1-to-1. Does that make sense so far? If you change the domain up a bit, you can make it 1-to-1. So when you look at this question over here, when they're saying the smallest value for which it's 1-to-1, they're saying, what number can you make x bigger than equal to over here to make it 1-to-1, or what's the smallest possible number? Because if you did x bigger than equal to, let's just say x bigger than 3, for example, is this going to be 1-to-1 now? It is 1-to-1, yes. But is 3 the smallest possible number? Does 2 also work? Oh yeah, 2 also works, yes. Does the number 1 work? Ah, yes, it does. So my point is, what's the smallest possible number? The smallest possible number, you can tell if you have the graph in front of you. Isn't it going to be where the peak is? Where the lowest possible point is going to be? See what I'm getting at? X bigger than equal to 0.33 recurring is going to be the smallest possible number. That's what p is supposed to be. So if you have the graph in front of you, that's very easy to do. Like if you have the graph in front of you, it's very easy to do. Like this graph over here. If you have the graph in front of you, it's very easy to do, right? You're going to identify it's going to be this number onwards. But in the actual exam, they don't give the graph to you. So how do you know it's going to be 1/3? Think about it this way. It's always going to be, for smiley face parabolas, it's always going to be the vertex, isn't it? It's always going to be this number onwards. Yes? And isn't this number, if you recognize, it's going to be the vertex? And when you've written this question, when you've written it in this form, doesn't that make it really easy to find what the smallest possible point is? So you can use this particular form to find the smallest possible point, which is when x is equal to 1/3. And that's how you found p is equal to 1/3. Because when x is equal to 1/3, that's where the smallest possible point occurs. And if you do x bigger than equal to 1/3, that's where you're going to get the smallest possible point for the domain over here, smallest possible value over here, to make it 1-to-1. Part 3. Remember for these rules, whenever you're dealing with inverse functions, 4 marks, you know what to do. You need to create the table. The table over here, it's very easy to do because you just start off with like f of x, inverse f of x like this. So what we did over here is, we've done the table first. No matter what for these types of questions, you always do the table first to illustrate what f of x and inverse f of x is. And then, you just copy in the information they give to you available. Right now, they're talking about this part, isn't it? Domain has to be x bigger than or equal to a third. That's how we wrote down x bigger than or equal to a third. If you have x bigger than or equal to a third, doesn't that mean by default you have the range of f of x? Because you can substitute a third into this equation, can't you? You can tell when you substitute a third in. I'm just explaining to you in real time the logic, how you interpret this. When you substitute 1/3 into 3x minus 1, it becomes 0. X is only going to be bigger than a third. If you make this number only bigger, this answer is always going to be bigger. So when you substitute a third into there to get a 5, 5 is going to be the smallest number then, isn't it? Because the answer here only gets bigger. This is a squared expression. That's how you know the domain for 1/3 gives you a range of f of x bigger than or equal to 5. And remember how you do? You just copy this and replace them, reverse order. A third becomes the inverse function range, 5 becomes the domain. Does this part ring a bell? You always start off the table first, right? And once you have the table, all that's left to do is you've got to find the actual expression for this, which starts off by writing y is equal to this. Are you going to make y is equal to this, or are you going to use this relationship over here? It's much easier to rearrange for the x by making y equals to this instead of this, isn't it? Which is what we did over here. Rearrange for that, it becomes x equals to y minus 5 equals to 3x minus 1 squared, which gives you square root plus or minus y minus 5 equals to 3x minus 1, and that's going to be 3x equals to 1 plus or minus square root. Like, this explains this working here, is my point. And you have to pick, is it plus or minus? Well, look at the range of the inverse function, right? This is the inverse function. It's telling you the range of the inverse function has to be bigger than or equal to third, which means it has to be positive, which means you can't have a minus component over there, because it's not going to guarantee it's going to be bigger than or equal to a third now, is it? So that's how you know to pick the plus version of that, which is 1 plus square root x minus 5 over 3 over here like this. Part 4, set of values of q for which this has no solution. F of x equals to q. What's f of x? F of x is this parabola over here. If you make f of x equals to 6, is that the same thing as doing this? Looking at which x values give you 6. Do you see my point? Whenever you make f of x equals to a certain number, if you make f of x equals to 7, it's the same thing as doing a 7 over here, dot, 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 looking at the x values and make that. Do you follow what f of x equals to a specific number means? Yes or no? So when they're saying f of x equals to q has no solution, they mean, first off, this is our graph for f of x. If we made f of x equals to 2, why would that be pointless? Does the graph even touch 2, is my point. Do you see that's what we mean by no solution over here? If f of x were to be equal to 2, this would have no solutions. You wouldn't be able to find what x values give you a y value of 2, because the graph doesn't even touch a y value of 2. If you made f of x equals to 4, does it even touch 4? You're not going to find any x values for that. Okay, that's what no solution means over here. So it's saying, describe all the values of q. Describe what f of x, what numbers is f of x going to be equal to? What are all the numbers that, if it were to be equal to that, is not going to have a solution? Well, look at where the graph finishes. This is the smallest possible point, 5. Anything below 5, and that's how do you describe all the numbers below 5 over here? Q less than or equal to 5. Excuse me, it should be q less than 5. That's a typo over there. That should be less than 5.